So today is Quadratics Day 7 and the last piece of information for Unit 1 on the quadratic function. So today you're going to look at the very last resort of solving a quadratic equation, and that is using the quadratic formula. So the quadratic formula is based on standard form. Remember, this is standard form. So you pull out the values of A, B, and C, and you apply the quadratic formula. It's the opposite of B plus or minus the square root of B squared minus 4AC, and all of that is over 2A. So this is the last resort, or it should be, because it's tedious. All right, so back when you first learned the quadratic formula in Algebra 1, there's a little song that goes to Pop Goes the Weasel to remember that. So you may have learned that in middle school. You can type this in on a website or go to YouTube and search the quadratic formula song and you'll hear it. However, I'm going to entertain you today and sing it for you. So the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So hence that is an easy way to remember the quadratic formula. All right, so we're going to solve these and we're going to inspect them carefully and choose the most efficient method. So here we have 2x squared plus 4x minus 5. We have all three terms. So the first thing I would do is see if it factors. There's no greatest common factor. So I need two numbers to multiply to negative 10 and add to positive 4, and there is none. So the second resort would be to apply completing the square. Most students don't choose to do that, but you could do that one on this problem. So we're going to apply the quadratic formula. All right, so from the quadratic standard form, we have a equals 2, equals 4, c equals negative 5. So plugging these into the quadratic formula, we have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So these values are not difficult enough to plug into your calculator. So we're going to do these by hand. We have negative 4 plus or minus the square root. 4 squared is 16. And I have a negative 8 times a negative 5, which is plus 40. And that's all over 4. So now I separate it to negative 4 over 4, plus or minus the square root of 56 over 4. And I get negative 1 plus or minus the square root of 56 over 4. When we do the unit on polynomials, we will work on simplifying those radicals. Okay, so this one, notice your middle term is missing. You don't have a bx term. So the easiest way to do it is by using square roots. So move your 18 over. Divide by 3. And take the square root of both sides. So remember, in quadratics, typically you are looking for two solutions. So you have a positive square root of 6 and a negative square root of 6. For this one right here, you would have 2 because one would be the addition part of the problem and one would be the subtraction part. Okay, so this one, remember I told you if you have all three terms, you need to set it equal to 0. So for this one, we have nothing that will multiply to 13 and add to -4. So we're going to have to apply the quadratic formula. Actually, I'll solve this one by completing the square for you. Okay, so you could apply the quadratic formula, but this one's pretty easy to complete the square because I have a 1 here and an even number in front of x. So if you remember this process, I have x squared minus 4x equals -13. So now I'm going to complete the square. So x squared minus 4x plus something equals -13 plus something. So I have here half of 4 squared. So that would be -2 squared, which is 4. So I'm adding a 4 here. So then this factors to x plus 2, sorry, x minus 2, multiply to +4, add to -4. So I get x plus 2 or x minus 2 quantity squared equals -8. And again, if you think about squaring any number, you always get a positive answer. So this one has no real solution. All right, so quadratic, I have all three terms. So can I multiply to 6 and add to 5? The answer is yes. I can use 2 and 3. So I'm going to factor to solve. It's already equal to 0. So I have x minus 2 or plus 2 and x plus 3. Set each parenthesis equal to 0. You get x equals -2 and x equals -3. Okay, another one where I have all three terms. So can I multiply to -6 and add to -5? And the answer is yes. I can use -6 and 1. So since this one has the 2 in front of the x squared, I'm going to go to that Algebra 1 method called the M method. So I have a -2x or a 2x squared times a -3. I get a -6x squared. So in order to use my -6x squared and get a -5x squared, I'm going to have a -6x and a +1x. So I bring down my first terms here, my first and my last. So now I have 2x squared minus 6x plus x minus 3 equals 0. I'm going to factor by grouping, so I can pull a 2x out of this. So I have 2x times x minus 3. Out of this one, I can pull out a +1. Equals 0. So now I take out my common factor x minus 3 times 2x plus 1 equals 0. Set each factor equal to 0. So here I get x equals 3. And here if I subtract 1 and divide by 2, I get x equals -1/2. All right, so last one. So this is in the form where we're going to use square roots. It's the quickest and most efficient way. So let's divide both sides by 2. 9. Take the square root of both sides, so I get x minus 3 equals plus or minus the square root of 9, which is plus or minus 3. Add 3 to both sides, so I get positive 3 plus or minus 3. So I get 3 plus 3, x equals 6. And I get x equals 3 minus 3, so x equals 0. Okay, so that's the end of the first quadratic unit. There's an assignment you can get started on, and you will have time in the next class period when I see you to work on it and ask questions. Have a great night.